In this video, we're going to talk about payout annuities. So basically, the situation that we're talking about is if you removed some fixed amount from an account each time period for a particular number of years. And then suppose the money sitting in the account while you haven't removed it or withdrawn it yet is still earning interest while it's there. So I'm going to highlight these different pieces in this formula. So we have that A, which is going to be the original amount of money in the account. So this is like our original account balance. The P here is going to be the amount that you're removing each time period. And then we have 1 minus 1 plus R is going to be the interest rate. N is going to be the number of time periods. So we have R and N showing up together. And then T is going to be the number of years that this is happening for. Okay, so just to be extra specific, A is going to be the original account balance. P is going to be the amount you withdraw each period. And then R, N, and T are exactly the same interpretation as the savings annuities, okay? But our A and P have a different meaning. Okay, so suppose we wanted to figure out how much we need to have in an account which earns 5% APY to be able to withdraw $1,500 each month for 25 years. So we can think about which pieces of this formula that we have. We're trying to figure out how much we need to have in the account. So we're trying to figure out what does A need to be so that if R is 5%, so my interest rate is 5%, and I want to withdraw $1,500 a month, that's going to be our P. For 25 years is going to be our T. And since we're doing this each month, our time period, or N, the number of time periods in a year, is going to be 12. So we can plug all of that information in to solve for A. So we've got A is equal to, we want to withdraw $1,500 per month, 1 minus 1 plus our interest rate that we're earning on the account is 5%, so 0.05. We're doing monthly time periods, so N is 12. We have raised to the negative 12 times 25 for the number of years. And then we're going to divide this all by 0.5 or 0.05 divided by 12. And so basically, we just need to plug this into a calculator, and this is going to give us our A. So after plugging it into a calculator, we get that A is equal to 256,590.07. So that's going to be $256,590.07. So this is how much we need to save up into that account if we want to be able to support withdrawing $1,500 each month for the next 25 years. This isn't listed in the problem, but if we wanted to figure out how much we need to deposit each month to be able to save this up, we can go back to the previous type of problem, which is the savings annuities. This was in the previous video. We know that we want our ending balance to be the amount that we need to save up. And we can solve for this P right here to figure out how much do we need to be depositing in the account. Maybe I want to save up this amount, let's say in the next 30 years, right? Maybe we're like saving for retirement. So I'm going to write this question down. So how much So this would be like if we're saving up for retirement, and then when we retire, we have this much, and then we're withdrawing $1,500 a month. So to do this, we just use the savings annuities formula. So we have that 256,590.07 is equal to, if we look at the formula over here, we have the amount that we put into the account each month, 1 plus R over N raised to the NT minus 1 divided by R over N. So we're trying to solve for this P, and then we have 1 plus 0.05 over 12 raised to the 12 times 25 minus 1 divided by R over N, so 0.05 divided by 12. And we just go ahead and solve for P, which you can do in your calculator. We end up getting $430.87 is what we need to set aside each month for the next 35 years to be able to save up our desired amount of $256,590.07.